Hi, my name is Meg Kelly, and this is my final presentation for the Analytics 6983 Topics class. We'll be going over the merger and acquisition analytics for Alicorn VC. So just to introduce this project, we'll be doing an analysis for Alicorn VC, which is a venture capital group that focuses on investment strategy. The data that we'll be using from this company includes investment statistics for a variety of industries, investment types, and company sizes. The goals for this analysis are to see which factors contribute to profitable investments, which factors negatively affect an investment, and to build predictive models for a few key target variables, including MOIC and acquisition values. Prior to analysis, we took some steps to prepare the data. So the first thing we did was we cleaned the data. Irrelevant fields were removed, including a couple of fields that didn't have any data at all. We also looked at the variables that were dependent on each other. So for example, industry group and industry code basically gave the same information. So in some cases, we removed one of the variables. After that, we looked at the missing values. This data was missing a lot of instances. So an autofill script was applied to the data set within big ML to fill in those missing values. And finally, we ran an anomaly detection function via big ML once again to identify significant outliers. Those outliers were examined and removed case by case. For this section, we'll be looking at the general analyses and their goals. That includes later round performance, investor outcomes, anomaly detection, and company age. First, we analyzed the later rounds. According to this chart, Series C and D investments do very well, and this can be seen even when compared to earlier deal types. This chart compares the total preferred capital raised in millions of dollars and the last VC post value raised in millions of dollars between deal types. There's a pretty clear linear correlation between these two variables when comparing the deal types. The main deals, C, D, E, and F, perform the best, followed by the subtypes, C1, C2, etc. Series G, D2, and E1 are the worst performers, clustered at the bottom of this chart. Interestingly enough, some later deal types actually perform better than the earlier types in certain industries. For example, Series E and F do well in the semiconductor and healthcare industry. Next, we wanted to look at how preferred shares or preferred capital raised influences the multiple on invested capital, or MOIC, and the acquisition post value. In other words, we want to see how our investor outcomes were influenced by preferred shares. On the top chart, multiple on invested capital is being compared to total preferred capital raised, and we can see that while there is a fair amount of variation in the MOIC metric, higher values of preferred shares tend to result in a lower MOIC value. Essentially, more capital raised does not necessarily result in a successful investment. The bottom chart compares WAMOIC, a similar metric, to total preferred capital raised. The result is quite similar, with a bit less variation. Finally, we examined acquisition post-value as compared to preferred capital raised. There is very little correlation here compared to the previous two metrics. Of note are the two outliers on the far ends of each axis. These may need to be removed and could be causing significant skews in our data. Overall, both MOIC metrics certainly have an influence when it comes to investor outcomes, but acquisition post-value doesn't necessarily have a say in the result of an investment. Next, we'll look at a few predictive modeling scenarios that were made for acquisition post-value, MOIC, and total preferred capital raised. First, we'll look at acquisition post-value. For all three of these models, the OptiML function in Big ML was used to generate the best models, and the top model was selected for evaluation. With the target variable of acquisition post-value, the top model was a boosted decision forest. The model relied heavily on the acquisition size variable, with that field contributing to 82% of the model. In looking at the evaluation metrics, we can see that this model performed very well, with an R-squared value of 0.82. This indicates that the model explains 82% of the variation in the dataset. Additionally, the mean error values for this model were significantly lower than they were for mean and random decision-making models. I would be comfortable using this predictive model in practice. The second OptiML generated was to predict MOIC. The top model here was a logistic regression model with percent preferred capital raised, acquisition type, acquisition year, and last VC deal type being the top contributing variables. This model did not perform well. While it was 84.7% accurate and it was quite precise, it did not do well in terms of recall. This means that a very low percentage of relevant results were classified correctly by this model. The F measure is a reflection of the poor balance between precision and recall as well. MOIC was a very difficult field to predict for, and I don't think that any of the models generated by the OptiML would be usable here. The top model produced by the OptiML function here for total preferred capital raised was a random decision forest model. It was extremely effective with an R-squared value of 0.98 and extremely low mean error values. However, the top contributing factor was total preferred capital raised combination, as well as total VC capital raised, and I think this might be the reason for the model being so effective. These fields, along with the target field, are quite dependent on each other, which may lead to problems in developing a model that explains all of the data. I would need to investigate this model further and create some more without these two fields to determine whether this model is truly valid. Next, we'll move on to our secondary analysis goals. In looking at the performance of investment returns by industry, we can see that information technology is consistently a top sector. Healthcare also performs quite well. Energy is our worst performer with an extremely low WA-MOIC level. The scatter plot depicts specific industry codes and compares their MOIC and WA-MOIC values. Interestingly, healthcare-based industries, specifically pharmaceuticals and biotech, tend to have a much higher relative WA-MOIC level, whereas media has a much higher level of MOIC last round investors. Software, specifically business software, was a top performer once again among all industry codes. This scatter chart uses bubble size to depict the number of employees at a company and color to depict the year a company was founded. It compares WA, MOIC, and MOIC values, like the previous scatter chart. Companies founded in 2011 performed incredibly well, as did 2012 and 2013 companies. 2013 is an interesting data point with a massive number of employees seen. The general period of time of success lines up with the economic recovery post-2008 financial recession. These maps show the MOIC and WA-MOIC rates of each country by color, respectively. The United States was excluded because it placed an extreme skew on the data. We can see that England has a very high MOIC compared to most other countries. However, Canada, China, France, and Turkey perform much better for the WA-MOIC metric. WA-MOIC represents a weighted average, so it seems that the last round investors do well in England, but the other countries seen in the second chart have better investment returns overall. For industry and sector analysis, we can see that once again, IT is extremely well performing for total preferred capital raised, followed by business products, consumer products, and healthcare. Among the IT sector, SaaS and mobile verticals were solid performers, and e-commerce was another good vertical within the customer products industry. The life sciences vertical within the healthcare industry was the second highest for the total preferred capital raised. When looking at how this chart has evolved over time, healthcare has seen significant growth, IT has remained somewhat stable, and business products and consumer products have both declined considerably. When looking at the performance of M&As versus buyouts in terms of MOIC and acquisition value, it's clear that buyouts are well distributed for acquisition post-value, but have mostly low MOIC values. This indicates that while buyouts may be high in terms of value, they may not be worth it in terms of investment returns. Mergers are much more spread out. Of note are two extreme outliers. This can be seen on the scatter plot. These could be isolated events or they could be errors in the data. Either way, they definitely should be investigated further. Age was a significant factor for the mergers and acquisitions events model. However, this model performed very poorly, and I would not recommend using it. M&A events are difficult to predict for, so I'm unsure of how valid the company's age as a predictor truly is for this variable. When looking at acquisition value, it is not a significant contributor. Based on the information provided, there are several actionable insights that we can take from the analyses and models generated. Some significant factors that indicate investment return include the country of origin, type of investment, and the industry. Some basic company statistics, like year founded and number of employees, as well as preferred capital raised, seem to be less relevant to the outcome. Software and healthcare are both top performers, and healthcare in particular has seen a large amount of growth, whereas consumer products are not doing very well. Predictive models can and should be used for certain fields, like acquisition post-value. Slide 9 in particular has a solid model that could help predict successes with this particular dataset. However, there are a few limitations within this dataset, like the missing values and the difficulty for predicting MOIC, and these should be kept in mind when models are generated in the future. This slide contains all of the references that I used when generating this project.